Here, what we do with these complex scenarios. So, first of all, I want to say, I'll show you some numbers. I want to say that we develop composite utility poles that are about 20 inches, 24 inches in diameter. The central message of this is that these poles resist forces up to 120 feet height. That's the first message. So some guy asked me, do you use 120-foot high poles for your street lamps? I said, wait a minute. I never said I use that for a street lamp. That is for high tension transmission tower replacement. You get it? Sometimes, I assumed already he is going to correlate my 120-foot statement to a high tension transmission tower. He did not. He immediately asked me, is that for a street lamp? Do you understand the message? So that's what I mean when I say everybody knows what I'm talking, therefore that's my fault, not his fault, All right. So what does that mean? 120 feet high transmission tower, the utility pole. It has 3 or 4 implications I'm going to tell you. Number 1, of course, it is going to resist forces, wind forces, tension forces with snapping of some wires, non-snapping, you know how they do the design. It has to resist all these forces. That's what it does. Number 1. Number 2, it is probably 1/4 the cost of your typical transmission tower, what we call lattice structures, It's number 2. You call lattice structure? Okay. Number 2. Number 3, I can erect it in a day. Number 4, it is so lightweight. In New York City, I wish I had the slide, I don't have it here. In New York City, 2 people carried a 60 or 80-foot pole to put it in their backyard because the crane wouldn't go through their doors and what have you. So the flexibility for installation is the issue. Okay, but the punchline, most important punchline, is fire. I will show you some slides on fire. All your steel transmission towers melt. Here, I will show you some numbers. We burned this at 1100 degrees Celsius for 3 minutes. We still did not have any reduction in the properties.
1100 degrees Celsius.
See, you will see some of that here. Okay, that's a brief. I can go on and on, but I won't. I want to wrap it up because if time permits, I want to show you something else. My passion is about housing, low-cost housing for needy people. Anyway, let me finish this. Anyway, if I saw it here. Okay. Number of wildfires, U.S. wildfires. You see, 30,000. That is how it looks in the field. Very dangerous. Billions of dollars of loss. Composite material advantages over conventional materials. Here our goal is to understand the performance of the pole under wildfire. What is a wildfire? First I need to define that, right? A wildfire, you have one kind of intensity at the ground level, you have a different kind of intensity at the top, and some third kind in the middle. So the EPRI, Electric Power Research Institute, defined that all these fires are moving fires. They defined a wildfire to be sustained by a structure is 1100 degrees Celsius for 3 minutes. And then it will move on.
Yes, sir.
Okay. Now, so what are the issues? Nature and characteristics of the wildfires. You see there? What is that telling you? So sometimes you reach 1100, that's what, not much, but like instantaneously hits 11 and moves on. And that is on the vertical axis. On the horizontal axis,
The time.
that is the time. So this is defined by EPRI, Electric Power Research Institute. The temperature ranges they're finding from their field measurements are given to you there. Anyway, these are fire severity categories. I won't go there, no need to go there. Here are variety of test procedures that ASTM suggests. There are many issues that one needs to, I won't go through all that, but somebody was asking me yesterday, that's why I put it up here. The most important test is a corner testing. That is the one. Here we have to take a full-scale thing. Of course, another important test out of this is tunnel test E84 and E119. We have to satisfy these two as a very minimum. And there are many others not quite as critical as those two. There we go. E119 test, corner fire test. Fully constructed and exposed to 1260 C for 8 hours. That's called a corner test. How long, how much will it survive? What is the remaining strength? Those are the issues. Test ends when unexposed side reaches a threshold value, and that number is given. This is one kind of a test. That is the fire shield. What you are looking at is a fire shield. They have this is a company is developing its own test procedure under a full scale. So there are certain things about the fire shield, maximum temperatures. You remember the 1100 magic number I said? What is the energy that is put out? All that. Look at the TG value. We all keep talking about it, how the TG is going to dramatically drop. Look at also, please, the roughly the TG temperatures. They are around 80 degrees Celsius, around, somewhere around there. How do you improve the fire resistance? What is the effect of fire protection coatings on the residual flexural strength? Use of flame retardants such as the aluminum trihydroxides as a filler, halogen additives, use of phosphorus as a retardant, and intermittent coating. The first three are the additives in a resin. The last one is external coating. On top of it, we have a fire shield. So there are three different ways we want to protect. This is the SEM view, layered fiber architecture of a composite. And let's look at the implications of it before and after fire. Obviously, that's before the fire. And as you can see, this is one layer laminate type thing, if you want to call it. This is the another laminate type thing. So you have this alternatively. That is the cross section under SEM. So we torched it.
So if you are mixing this type of material, fire-resistant material, to enhancing its capacity, maybe they may have some side effects. They are causing voids or something. This chemical.
Definitely, you lose some strength. There's no question about it. We know that. So instead of having your is 0.01, we need to reduce that to 0.008. Something like that. This is the compromise you have to make when you're doing a design. See, we recognize that, and what I want is, that's my technician there. Wonderful technician. I lost him because he retired, but wonderful guy. So this is a sandwich composite, and that's a 1/4 inch sandwich. That's a balsa wood, and we have about 24. We call it. We talk about it in Fahrenheit. That's about 11, 12, 1300. So my message to you is, this has about 45 layers to make a 1/4 inch. I was asking somebody this morning, or yesterday, right? Yesterday, they were using 45 layers. That's what I was, yeah. So that 1/4 inch has 45 layers of 24 ounce per square yard composite. And you know what? It took us, adjusting the flame, we have certain standardized measures. So, in terms of testing, we put an acetylene torch about, say, 6 inches from the surface, and for every layer took approximately 10 seconds of it. So the total, it is about 26 minutes, before the fire reached the core material. So that is how good composites are in terms of fire. Another thing, I have a different core material than balsa wood. In this case, this is a carbon foam. The message here is, as a torch, that is about 2200. After about 4, 5, 10 minutes, that's my IRT, infrared thermography. The other side is still 62 degrees. You can keep your hand on there. This is after half an hour or whatever, back side of the panel. So the thermal resistivity can be controlled depending upon the foam that you're using. Of course, we use a carbon foam for some other reasons. Never mind, whatever the reason, if you use the right kind of a core material, you can get that. Incidentally, I didn't say it. This particular one is we had to test it for the destroyer class of ships, where our role was to build the deck house, or the top part of it, keep it lightweight. This is a corner test, I told you, E119 type test. And again, we tested real fire, 10 feet by 10 feet by 10 feet, and it has to survive a minimum of 3 minutes. A minimum. And we have to worry about smoke, toxicity, and those kinds of things. As the fire goes on, these are the chemicals released. We want to make sure that they are within the parameters that does not create carcinogenic effect. So, fire performance evaluation of 4-inch thick load carrying composite wall. I did that for my, we built a local school, somebody built, not me. I volunteered to provide my panels, and before I provided, they wanted me to test for fire, and that's what we did. And again, we satisfied the requirements. This is a composite, prefab composite panel, satisfied the requirement. Again, the very important test when it comes to fire are two, E84 and E119. This is E119. Of course, we have other things like opacity and the visual thing and what have you. Those can be exempt, but the two are E84 and 119. Fire performance evaluation of a 4-inch thick load carry. Yeah, I just talked about it. I won't go into a lot of details, but so this is the wall that we have installed in the school. This is the E119. That's our panel that we tested. So we developed a multifunctional non-load carrying, load bearing. So the ignition temperature is 70 seconds, no visibility, that the opacity I was talking about is 160 seconds, only that's almost 3 minutes. After that, you cannot see. So to escape, I mean, you know. So up to 160 seconds, you can see and get out. A lot of people don't know it. In fire, the deaths are not due to heat, but due to toxicity. So various flame of exposed surface. After 11 minutes, there is a standard for it under the E119 flame of joints. After that's a critical one. So they have standardized that stuff. So implications of the above test for the utility poles is fire performance can be enhanced using the coatings. Phase flame burn occurs due to intermittent coating and layered fiber construction. That's what I told you, 40 layers of fiber delays it up to 30 minutes. Typically, the fire ratings are based on half-hour rating, 1 hour rating, and that rating in concrete building depends on the cover, clear cover, you know, like a half-inch cover is 15 minutes, 1-inch cover is half hour, 2-inch cover is 2 hours, things like that. That's what we are talking about.
What is fire rating?
Huh?
Fire rating.
Yeah, I mean, that would tremendously enhance. Again, can you, what is it? Fire, think of it like this. Some kind of a Band-Aid, leave it there. Of course, the material has to, you know what a Band-Aid is, right? So we wrap around it. That's a barrier.
It gets burnt but protect the inner core.
It won't be easy to get it burned. It'll take a while before it burns.
Yes.
So, in other words, it's not like a paper it'll burn. You have to have a sustained fire before it burns. Okay. This is a double wall pole. I won't go there. In conclusion, this study has identified FRP burning as a phased process due to layered fiber construction, even without intermittent coatings. This multi-stage burning process appears unique in the fire behavior. Utility poles are able to survive general fires, and in conclusion, we can see that this will help the utility industry to use the FRP poles.
Sir, what is the cross section of that utility pole? Is it a hollow or
It's hollow.
hollow?
It is hollow. It is. I have several cross sections depending on the length of the cantilever pole you want. They are 12 inches, 16 inches, 24 inches and 18 inches. Typically, the cross section is for lower poles about ½ inch. For higher diameters, it is about 3/4 inch.
And it is also layered.
Oh yeah, all are layered. And as the thickness increases, the number of layers increase.
So how can you correlate that to FRP bars? These results are
All I can say is if I expose an FRP bar, for example, say the FRP has so many things, if I expose them to a fire of 1100, so it is going to take, let's say the 1/4 inch bar, as I said, say 40. So each layer is 1/160 inches thick. Right? So all I'm saying is 1/160 inch thickness is 10 seconds to burn through. Now your ½ inch bar, make it a 1/4 inch, will take about roughly 30 minutes. That is without the concrete cover. With the concrete cover, you get a better value. Okay, so that gives you a quick presentation on
So for 12-inch diameter of your utility pole, you just said that the cross section was ½ inch, right? And it goes up to 100.
not cross section. Thickness is half.
Thickness is ½ inch. And it goes up to 120 feet high.
No, I didn't say that. The 18 inch and 22 inch ones go up to 120 feet.
Okay.
The ½ inch ones go up to, let us, I don't know, I don't remember now, 60 or 70 feet.
Right. So even for the 22 inch and the 18 inch and the 22 inch, you just mentioned that it's 3 inches to 4 inches in thickness.
3/4 inch
3/4
means
inch.
0.75. Yeah.
What's the the base that you've installed for it to resist such high forces?
Concrete.
Okay, you've installed concrete as the base. Right.
I didn't want to get into a lot of details. You know what? Not only I installed concrete, I used the guide towers to make it a self-stabilized unit. Guide cables. What does that mean? You know what that means? That means that I am preventing the tilting of it by tying down the guide cable onto a very thick concrete foundation platform. Therefore, I'm using as little a footprint for it to be stable. Did you get what I said? There it goes. I'll show them in 5 minutes. There is another presentation here on Ollie.
Ollie, yes, that one.
This is on housing. Okay, this is kind of my passion. Okay, the reason I say it's my passion is I just told you I am able to develop modified wood of a higher grade, and some people, industry guys, want to come and talk about it. This is what I told them. If you are not thinking in the future about how to utilize the modified wood for housing, please don't waste your time. They're going to see me on September 15th and 16th. It's a great passion for me. So these are sustainable buildings we are talking about, right? I won't go into a lot of details. I'll just pass through. Okay. This is the FRP modular building. And there we go. That is my natural fiber panels I generated. So what I'm telling is, we are talking about the green composites for energy efficient buildings. There is only one of the 8 points, or in this case I only showed 6 points, that we need to be worrying about in terms of an efficient housing. One of the 8 or 6 points is the material. It's only one. There are many other issues that we need to bring in to make it more energy efficient. Okay, I'm going to talk briefly, breeze through some of the aspects. I won't delve into it. Each issue is a big topic by itself. All right, the first one is, you want to have a durable, strong, stiff composite panel made of natural fibers, natural resins with 10 times lower embodied energy. That's the first one. The second one is the modular panels with built-in, I don't know, trombe wall concept or not, I won't go there, but you need a special wall from the heating, cooling. All that means is you're going to draw the geothermal energy. How do you draw it? Not by a pump, by a convection principle you draw that. Anyway, I'll leave it there, but that's another one. The third item is the sandwich paneling concept. You saw that there. That is the sandwich. I have a shell at the left and right. This is the trombe wall concept I just briefly mentioned. And at any rate, then I have the modular panel with your solar panels or whatever. And then we're talking about smart windows and doors, what we call micro blinds. You know what that means? The high-end Benz cars, high-end, not low-end, have glass panels and the car doesn't get heated up inside. How? What they have is a glass panel with a very finely etched surface which shuts off the heating spectrum of the light, only lets in the cooling spectrum of the light. So we have panels like that.
Projections at micro levels.
Yeah. I don't want to call it projection, we call it etching. You etch it in a certain direction. It's like I talked about boards. Sort of the same. You have to have a proper angle, you have to have a proper depth, you have to have, all that kind of. That's why they etch it in the manufacturing itself. Anyway, forget about all that. What that implies is you can get a window pane for you, especially for India, that will be angled in a manner to send only the cooler part of the spectrum, reflects out the warmer part of that. That's the principle. Anyway, that's another. So then, a roof garden, is it?
Yes.
So these are the ones we incorporated. Okay? All right.
Sir, won't the roof garden make the fiber damp?
You see, we have special plastic fabrics that would not let water go down. On the other hand, do you know water is the best insulator? You can't get any better insulator than water. So any dampness is going to be shut off. And do you know that 30 to 35% of heating or cooling requirement is because of the roof. 30%, think about it. So if I can control the temperature, I'm saving not 30% because of other losses. And even if I save 20%, that's a lot of saving, right? That is the thing. So same thing with human being. They lose a lot of heat for winter from the head. That's why everybody wants to cover their head, without realizing why they're doing, but it looks good, sounds good, saves good. So therefore I do it. That's what it is. Okay, sorry. So here is the modular concept. I got a patent back in 79. That here are, anyway, I won't go into detail, but that's a modular concept. And the beauty of it is, here are the modular. So these come up with various prefab, various functionalities, like you have conduits, for example, you have connector details, another example, you have joints in a manner that would transfer the shear forces, all that good stuff. And the windows and doors are fit because you just shovel it in, So you can see how I can control even the colors. So I can get a variety of colors. And here is the foam core. Here is a building we built in 1992. Looks exactly like that today. Here is a pultrusion process with foam. This is a polyurethane foam core. You can have many different foam core, but this is one of the many. That is how we built that building. That's the pultrusion process.
On the natural compost.
Yeah, and now we can think in terms of having these openings. That's what we are doing now. And this is the carbon foam, low-grade carbon foam panel. A variety of things, but this is that school building I'm talking about. That's where we did. You can see I can get any color I want. I can get a brick effect, adobe effect, smooth effect.
Yes.
Intertech is the one that's helping us do all this work. We did some work on rammed earth. This is only good for rural areas, not for urban areas. I built the building in Alaska, and there was about 7.2 earthquake, about 50 miles, the epicenter, and it survived. That is the Alaska building. How you do the rammed earth, I won't go there, but the message is, it is so extraordinarily heat resistant. That is the message, or cold resistant, whichever the way you call it. These are some of the details about that. It looks good. It's not an inexpensive thing, I admit, but not for everybody. It's only for rural communities where you use the local material. That's the word.
So the foundation is a concrete.
No, it's all rammed earth. It's all rammed earth. We learned this from Chinese. There are rammed earth buildings even in India, but that's only in the Kashmir, Nepal region, and they call them tulos. I visited one of the tulos that was built in year 600, 20 or 21 in that range. Functional tulo.
Is there any damp-proofing for this basement?
Yes, they do have. Yeah, that's very important, very important. Or else you get the mold problem. There's a beauty with the composite. Composite never builds up a mold, That's a different topic. I did some work in that area. Okay. I won't go there. These are all different. We always, as much as possible, money given, we always do a post evaluations of these structures because they're all different concepts. We don't know what's happening. I can sit here and talk, but the proof of the pudding is how it is doing in the field, you know. So this one, I thought this as a, I thought this as a video. This is built in, I forgot, few hours, that modular building.
The master effect of that will remain the same as in general concrete, I think, on the wall. For the appearance point of view, marking it.
Yes. You don't, correct. You don't find any.
Swelling of the whitewash will take place.
That's right. So we are now working on geopolymer buildings. I just got some dollars to do that, and that is the building we are going to build about a few miles from my office, and we are going to let needy people occupy it and then test it for a variety of things. This is just one of the several tests we are conducting. That's a geopolymer panel. That's the point. Geopolymer panel. That's the building. Here is some of the factory-based, that's a calcium carbonate we are using. See, when your economy is advanced, you want to sound sophisticated, right? You want to. Okay, good. But with that, you're also generating lot of waste, lot of recycling. So we are working on carpet recycling. That's what we are doing there. I won't go into detail, but that is we recovered the calcium carbonate, which is the backing of the carpet material. We are reusing that recovered in a pultrusion process, and we did that. We got as good a results as virgin calcium carbonate. This is the insulated sandwich with the discarded foam core. So where is the foam coming from? Discarded mattresses. We discard 14 million mattresses every year in US. Where would we bury it? So that's what we are doing. We conduct the thermal conductivity tests all along, and we put that in the wall floor panel that I showed you in my earlier slide. So the foam in here is that discarded mattress. That is the location where we are building. Oh, those are the conclusions. But that concludes my presentation. A broad brush presentation, a lot of detail. Many PhDs work on these kinds of things. So this has a lot of theory behind it. I just showed what appeals to people, not the theoretical part. That doesn't appeal to. That's a big drag on people's time and effort.
So have you worked with thermoplastics in this foam?
Have I worked with?
Thermoplastics, like PE, you have your polyethylene.
Oh yeah, we did.
These are
We did.
using the PE and
Oh yeah,
making-
yeah, we did. You know, in US, we discard 20 million railroad ties. What I suggested was, instead of trying to bury that in the landfill, we take the beat up tie, is 20 million a year, mind you. Take a beat up tie, wrap it with a fabric, and then all the thermoplastics are recyclable. And we recycled it and installed it. I don't have that presentation here, but yes. So, of course, you have to characterize all these things. These are not simple and easy. It's a lot of work, you know. So, I mean, a lot of preliminary work of how you characterize, how you're going to manufacture and all that, but we did. And that's where we have applied it. We have, I don't know how much you know, about 75 to 80% of our plastic consumption is thermoplastics. Only 25% is thermoset. And thermoplastics are highly amenable for recycling. And we wrapped the old tie and then heated the thermoplastic as like a bread dough, and then we poured it in, and that's what we did. There are many other recycling applications, but this is appealing because you're suddenly talking of 20 million ties a year. So I enjoyed working with you all, and if you have questions, please don't email me anything till I return back. That is the 24th of this month. So then, I mean, I'll be able to respond immediately, or I'll ask somebody to respond on my behalf. Otherwise, it may be buried. I get 200 emails a day, so I get buried. I don't want that to happen. Thank you all.
Thank you so much, sir. Is there any material for GFRP that we can recycle and remanufacture for it?
As I told you, any thermoset based material is currently not recycled, but we can recycle it. I'm getting a patent on that.
Yes. But
how do you recycle it? That's the next question. There are two ways one should think about it, or maybe three ways. One is a brute force method. That is, you grind it, spend a lot of energy, use that as a filler material. The other is use this as fuel, but that generates a lot of greenhouse gases and what have you. What we are saying is, you heat it just to the point of TG, somewhere there. Soften it, don't melt it. That's the word. Somewhere around TG. What did I tell you before? There are only three things: time, temperature, pressure. When I have a judicious combination of these three, anything can be done, right? That is the soft spot we are trying to find. Okay, now we heat it for X amount of time. We infuse it after it is softened with a particular polymer that would react with the softened thermoset polymer under pressure. So I completed all three: time, temperature, pressure. And that will give you, and we got products that have been but I must admit, my statements sound lofty. All I have done was at a coupon level. I have not extended this to a component level or a system. So I want to qualify. But there are others I read recently are doing this kind of a thing. Maybe I forgot the names, maybe they are ahead of us. But it's going to be possible fairly soon, no matter what. But it's a little bit more involved. So, if you have any other item,
So you have produced timber which has equivalent performance.
I have produced what?
Timber which has performance equivalent to steel.
Right.
How have you done that?
Okay. Same, think of it along the similar lines. What did I tell you? Timber has two ingredients: lignin, which is the resin, and cellulose, which is the fiber. So, first of all, we want to typically typically timber has about 25%, 28% of moisture. We equilibrate it around 18, 20% there. That's right? Okay. So what we want to do is the following. We are finding a resin that is compatible with lignin. So we warm it, not heat it. I don't want to have a ignition going, right? Therefore, I warm it, let some of the air escape, and infuse the polymer that I'm talking about to have a bonding, covalent bond with lignin. In this process, I'm also compressing it so that not only my voids are filled because I removed some air, and then I am going to make the lignin react, and then I am compressing it. But you know what? The fourth item, what I am doing? The polymer that I am infusing is a reactive polymer with respect to water. Therefore, I'm reducing the water content from say 20 or 22% to 12% or whatever. That 10% margin is reacting to with the resin that would polymerize the thing. I got a double advantage. That is, I have reduced the water content, therefore I increase the strength. I've reduced the void content, therefore I increase the strength. I've compressed the wood, therefore I have increased the strength. Thus, I was able to obtain, do you get what I just said? Thus, I was able to get about 30 KSI to failure.
Yesterday you told about the FRB bolts, like the tension in the bolt, it reduces after some time.
Repeat what?
The tension in the bolt is lost after some time. The tensioning which you do. So is it due to the softening of the resin or?
What does tensioning mean? It has some force. Obviously, this force has to be locked. Otherwise, it will go back to zero, right? When I lock it, what I have done? I've created a pre-stress. Then what I have done? I've created a creep problem. And then what I have done? I've created a local stress concentration problem due to the drilling of those or creating those threads. So all these, it may not lose overnight or in 2 days, but I can assure you it will lose almost back to zero in a month or so because of all these reasons. And more importantly, I told somebody, that gentleman there, Keshav, is that your name? Okay. I told him, never ever cut an FRP rebar because you are cutting the cable, fiber. And
You use a steel bolt.
then you are left with only the localized stress resistance offered by resin, which is very low. Anything else?
So without cutting, how can we adjust the length and also?
I wouldn't even go near that. I wouldn't even think of cutting it, period. You're wasting your time and money, you know. No, you don't even think about it.
Just order as the
Oh, we have to order what length we have.
you need. Yeah.
Yeah, I wouldn't even think about it. No.
The dimensions cannot be altered in any case.
See, a manufacturer telling you, I'm glad. You see, he just graduated from college. Why did I say? You wait 5 more years, you will see how he is going to be transformed.
Sir, when we are using eco-friendly formworks or panels, is there any recent change from GFRP bars to this, or it's our basis on their criteria?
Formwork, you said? Did I hear?
Eco-friendly panels.
Right. What is the definition of a eco-friendly? What is that? It is that if you use conventional resin system, you cannot recycle it. That is not a eco-friendly. So, if you want to have a eco-friendly panel, there is a resin known as PFA. You can try that. That comes from wood resin, you know. That is eco-friendly. Now, what I don't know is I haven't done any work with that particular. My colleague did, with the guy, my co-author Gupta did some work. We can talk about. I think it is expensive. That's a wood-based derivative or any plant-based derivative, you know. So I want to throw a challenge. That is, India keeps talking about pollution, especially in the northern states, coming from burning of what they call stubble, right? So the question is, how can we make a foam out of it and use it? That is where the innovation comes, you know. I tell the parents, you send your kid to a branch that is most unpopular today, so that when he is ready to graduate, that comes into maximum demand. I mean, that's a statement with a tongue in the cheek, but that ought to be the philosophy, you know. So how do you think about it? It shouldn't be so difficult to come up with foams that can go into a variety of panels. It doesn't have to be housing. There are many other cases where you are solving many problems. The future,
Insulation purpose.
that's one part of it.
Noise absorption.
Right. The thermal insulation, the noise insulation, all these one part. But more than that, if you juxtapose it in a manner with the shell, you can increase the strength, stiffness aspects of it all, and you don't have to use the non-eco-friendly thing. Thank you.
Sir, you have shown some modular prefab units. So what is the cost of that, sir? If we want to construct some 1,000 feet square feet.
What is what?
Cost.
Cost.
Of the PFA.
Oh. Cost, I'll tell you this. I have my cousin, a professor in business school in US, you know. So I asked a similar kind of a question. That is, hey, I'm developing these things. Is it okay to say I will have a 10% profit? That's me, I stated to him, 10% profit. Like all the costs, you know how all the different costs, right? You add them up. So I said at the end of it, 10%. You know, his immediate answer is, that's a stupid way of thinking. That's what he told me. Okay, why? Cost is a supply and a demand issue. These guys will drop the cost by 10, 15, 20% the minute their supplies are not moving. Okay. Anyway, that said, I'll tell you the cost now. We believe that the the geopolymer panels building that we are constructing now, maybe about 2/3 the cost of a regular construction for housing. That's too broad a statement, but it has other parameters associated. Well, I won't go there, but that's about a thumb rule based response to you. Am I making sense? Yeah, that's thumb rule.
The same concept.
Huh?
Yeah, the same concept of your building which you are making with FRP. So I think already IIT Chennai they have done with the FRG. Fiber reinforced gypsum panels 10 years ago. I think they constructed a multi-stored building which cost around 10 to 12 lakhs. Same concept, but they used FRG panels, gypsum panels.
Gypsum.
Yeah, fiber reinforced gypsum panels they have used. IIT Chennai campus itself they constructed I think 4
Good.
to 5 buildings.
Very good.
10 to 12 years back.
Sir, in the L13 type rammed up building, is the rat issues?
It is what?
Rats.
Huh?
Rat.
Rats,
Rats.
rodents.
Huh?
Rats.
RAT?
It can enter into the earth.
No. These are rammed earths. They are compacted. That's what the meaning of rammed earth, Oh, no. There's no such thing at all. These are.
Planning is done manually.
Huh?
Manually.
That is why I said that is not a very mechanized system. You see, it could be done, but
Because it is done in rural areas.
in the rural areas, that's right. Yeah. No.
I think the cost is a prominent factor.
Again, for rural labor force, rural material, this is not for a mainstream thing. Remember, not for urban areas.
Minimal uses of resources.
Yeah. So there are a lot of challenging issues. I would like some innovations done as opposed to, you have to do conventional things as well to make some money, right? We understand that. Nothing wrong in making money. But you make it, with innovation, that's even better. This message is for the guys who are manufacturing things, And even in the designs, you have a lot of fantastic innovations you can make, The question is, how you interact, you meaning we have university type people, we have industry type people, we have government type people, we have investors. So how you put the coalition together to make it happen, that is a challenge.
Yes.
Always it is. Nobody wants to believe anybody. That is the kind of a times we are in, right? So if you tell me the sky is blue, I had to scratch my head. Did he really mean it is blue or something else? So that is the state of mind we are in,
And to go along in the innovation sector, that is
Even tougher. Right. Immediately you say, if it fails, the guy is corrupt, that's the other side of the coin. So nobody wants to take a chance. But that's where we need to overcome that suspicion. Both sides. Research is not an easy business, 9 out of 10 times. I only talked about successes. I never said a word about failure. I had a lot of failures, let me tell you that.
codes even have so much gaps.
Huh?
The code,
Yeah.
it has so much gaps.
That is because we don't have enough information from the field. Unless we get a lot more info from the field, there is no way we can fill those gaps. But you said it right. We struggle with that too. It's not that but at some point I had to put this into practice, right? However crude it may be, however uneconomical it may be. So That's why we are really soliciting your inputs in terms of what is lacking, where is lacking, what needs to be modified. We are really soliciting that information.
And ultimately, on a positive note, it's a big opportunity for us.
Oh, it is. Look, it's a big opportunity for everybody
In GFR.
in a country like this where you have a housing crunch. If you can revolutionize the housing and reduce the cost, there's nothing like it.
Marvelous.
Sir,
Not-
actually, persons also, I mean, I don't know how to contact, who to contact. So, some 4 to 5 years ago, not related to FRP reverse or something, okay. Some ASTM code, we have had some clarification or some kind of challenge when we had been doing some experiments. Actually, we dropped an email to the ASTM concern guides, but no one we have responded.
You let me know, you send me an email, I'll make sure.
Not at all relevant to this.
Understand.
Some test related to composite materials.
You see,
ASTM standard.
please look, we are also busy. We cannot simply sit and wait to get questions and respond to it. Remember that, please. So ASTM, the whole thing is done on a pro bono basis. They don't give me a dime to serve on a ASTM committee. They don't even give me my travel allowance to serve on an ASTM. Leave aside, no, my point is, sometimes it happens, you may have to, that is why meeting people one-to-one, since I know you personally, I respond. But there are a lot of emails I don't respond either, you see. That's why developing the personal relationship helps.
At that time, we wrote on behalf of, someone wrote on behalf of our company. So, but we didn't get any response from clearly.
No, it happens. I'm not contesting your statement. It happens. We know that it happened with me. I forget about somebody else. I'm telling about myself. So, what can we do? We only have so many hours in a day, and we do our best. Leave it there. That's all I can say.
Sir, any DexLab design available in that manual? DexLab?
Any what?
That in the manual, essay manual, DexLab design?
Oh yeah. Of course, absolutely. I did the one-way slab design. You can follow that. Same kind of a thing. Yes, the answer is yes.
Sir, one question from online participants. So they are saying that as GFRP we can't maintain site. So what will be the development length if we are using?
Well, I gave you the equation for development length. Please follow that. They're all in those 300 slide package. Yeah. Those are very valid. If any, they are on the very conservative side. In other words, even if you reduce it by 20-25%, you're doing well. Primarily focus on the development length only on the tension side. Don't have to worry too much about it on the compression.
Because sir, you are doing this is from all of the participants, and we are very